Alright, this is Mr. Gillum, and today we're going to be looking at coordinate planes to determine how far away points are on the coordinate plane. And so I just want to do a quick review on how the coordinate plane works. It's made of two number lines, the x and the y number line. The x number line moves left and right, and the numbers get bigger towards the right. The y number line moves up and down, and the numbers are bigger the taller you get. In the middle is where they cross. We call this the origin, where the two number lines meet at 0, 0. In this example, it says that point A is located at -2, -5. So we are going to graph it -2 in the x direction and -5 in the y direction. And so that is where point A is located in the third quadrant. In this particular problem, it says to plot all the points 3 units away that have the same y coordinates as A. So I guess before we do anything, let's just look at all the points that are 3 away from A. There's a point there, and its coordinates look to be at 1, -5. There's a point 3 away right here. Its coordinates look to be 2, -2. There's a point here that has coordinates should be -2, -5, -5, and we have a coordinate here that has coordinates at -2, -7, -8. Okay, and so these are our coordinates that are 3 away from point A. And you can see I just counted 3 spots away on each one. However, this question asks us only for the coordinates that have the same y coordinate. So if point A has a y coordinate of -5, then I would know that 1, -5 and 5, -5 will be the points that it's asking me for, because they also have a y coordinate of -5. So when it asks us, there we go. We've got them plotted right here. Those are the two. Let's do another example, kind of like that one. And in this case, we have point B at 4, -2. So again, I have the x and y axes, the positive sides and the negative sides. And I'm going to plot point B at 4 in the x direction and -2 in the y direction, right there. And we're going to call him point B. Now, we're looking again for all the points that are 3 units away from point B. So there's one right there, 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 and there. And let's go ahead and label these points. It looks like 1, 2, 3, 4, 5, 6, 7, -2. Above, it looks like we have 1, 2, 3, 4, 1. 1, -2. And 4, -5. Okay, these are the points that all have a distance of 3 away from point B. However, this particular question asks us which ones have the same x-coordinate. So in this case, if B has an x-coordinate of 4, then the other x-coordinates that have 4 would be at 4, 1 and 4, -5. All right. Let's go ahead and throw a little fraction problem in here. Now I know there's 2 of them on your notes, so I think we're just going to do one of them. What I notice about point A this time is that it has fractions, and in those fractions they are dividing into thirds. So instead of making each of these worth 1, 2, 3, and so on, I'm going to make each one of them worth a third. And so each whole is actually 3 spaces. There's 1, and there's where 2 would be. So this would be 1/3, 2/3, 3/3, or 1, 4/3, 5/3, or 6/3, 2. Okay, and I'm going to go ahead and divide all my coordinate plane up so it's clear where all the numbers are. All right, and so in this case, point A is located at 1/3, -2/3. So I'm going to go 1/3 in the positive direction and 2/3 in the negative direction. So that's where point A is located. The question asks to plot all the points that are 1 2/3 from point A. Well, I could probably do 1 2/3, but I think that this is going to be much easier to do if I change it to an improper fraction. 3 times 1 plus 2, 5/3. So really I'm just moving 5 spaces up and down, left and right of point A. So 1, 2, 3, 4, 5. There's a point there. 1, 2, 3, 4, 5 there. 1, 2, 3, 4, 5 there. 1, 2, 3, 4, 5 there. All right, and so now these are all the points that are 5 spaces away to the left and right of A, as well as up and down. But we need to look at the ones that have the same x-coordinate as point A. So let's label these coordinates. It looks like I have 1, 2, 3, 4, 5, 6 thirds, or 2, negative 2 thirds, okay, because each one represents a third. And then I have 1 third, and then 1, 2, 3, 3 thirds, or 1, so 1 third, 1. And then backwards, 1, 2, 3, 4 thirds, so we could say negative 4 thirds, or we could call it negative 1 and 1 third. And then down 2 spaces, 1, 2, so negative 2 thirds. So you can think about that point either way you would like, either as an improper fraction or a mixed number. And then finally, the one way down here, it's over 1 third, and then down 1, 2, 3, 4, 5, 6, 7, down 7 thirds, so negative 7 thirds, or you could think of it as 1 third, negative 2, and 1 third. However you'd like to think about it. We're looking for the coordinates with the same x value. So if A has an x value of 1 third, then I would know that the two coordinates that we're talking about would be at 1 third 1 is a distance of 1 and 2 thirds away and has the same x coordinate, or 1 third negative 7 thirds, or 1 third negative 2 and 1 third, however you'd prefer to think about it. We're going to skip over the next one with fractions due to the length of the video, but I'd be happy to help you in class with this if you get stuck on it. The last question I have on the notes today is about a game board, and it kind of reminds me of Sorry a little bit. It says on the game board they have to move their pieces clockwise, so it even puts the arrows on here so we don't forget, moves them clockwise. And so in this case it says if each square represents one space, what is the distance between the red triangle in the second quadrant and the red triangle in the fourth quadrant? So how far is it? Now, unfortunately, when you're playing board games, you can't just cut straight across the map. So we're going to have to count all the way around. And if each space is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, that's a distance of 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's a distance of 12. 2, and that's a distance of 2. Now, even though I'm counting down, remember, distance cannot be negative. Okay, it's kind of like an absolute value problem. How far it is different than what its value is. So, in this case, I know that we are a total of 12 plus 12 plus 2 spaces away, or 26 spaces from where we need to be. All right, so that's it for today. We're going to work on the study hour assignment in class, and that's when I'll see you.